Alright, so where we going to start? Let's run back through this, right? So definition of a function. Definition of a function, f of x. So using our notation. So a function is defined as is a relation where two things happen. Or one number of two things. Definition of a function. Right? So remember over it's a relation in which two things happen. One, all in the domain, or in other words, all input values have an output. All domain, in other words, all input has a mapping. See that we use the term relation. We're talking mapping diagram. And the second is they're only map to one and one. Right? So the input has only one output. Or each domain must have one range value. It don't have to be a unique range value, meaning two different inputs can have the same output. That's what I'm going to say, unique. So we say if you have a unique output means every input have a different output. They all must be the same. But what has to be must have only one. Right? So as long as you understand those two things, then you pretty much understand what a function is as we move into stuff. So let's get right into notation now. So given some function f of x equal to, I don't know, 2x minus 3, and g of x means some x squared minus 3x plus 4 minus 4. Right? So we have these two functions. Alright, we talk about types of functions, types of graphs, types of all that stuff. So this would be considered a linear function because it would give a graph of a line. This function g is called a quadratic function because it gives a graph of a parabolic curve or parabola, which is what we use. Oh, parabolic. Alright, so parabola. So this would be the graph. This would be a line graph, right? How we know? We talk about something called the degree. So if I never used this term before, so degree is the power of the variable, right? The power of the variable. In this case, our variable is x. So what's the power of the variable here? If you don't say anything, the power is 1. If you don't say 1, you must put a power. Right? So for f of x, its degree is 1. For g of x,
so degree means power?
It's degree, the largest power of the variable. So I shall say the largest as input that. The largest power of the variable is the degree of the expression or the function or the equation. Right? So if you look at f of x.
Sir, the number can have more than 1 degree?
One variable? No. Each variable have just 1 degree. Right? So if I look at this, if x squared wasn't there, the degree would have been 1. Which means that part is a linear expression. But because of the x squared now, the degree now goes to 2. Any function that has a degree 2 is quadratic. So degree 1 means linear. Degree 2 means quadratic. Degree 3 we call it cubic.
Oh, yeah,
Degree 4 just said power 4. We can call it quartic function or quintic. All of that. You can have all these different terminals that we use, but yeah, so we base these things on degree. So we're not going to really mess with cubic so much at any higher degrees, but in my eye. But these two I want to pay special attention to. So when we start doing the graphs of these functions, we're going to see that anything with a degree 1, the graph will always be a line. And then anything with degree 2 will curve, like a parabola, right? With a certain line of symmetry and all of those things. So that is coming up in a little while. Alright, so we have these two functions. So let's do some typical questions. So part A could be find one f of 3. Remember these two, g of negative 2. 3, where f of x is equal to, let's say, 9. I don't want that one. Let's say it's equal to
4, 5.
5. And then part 4. Yeah, I'm putting some hard ones that we'll leave for later. We'll try and do that. Alright, so those ones will get the hard one.
G.
G of x is equal to some number. G of x is equal to 0. Let me do that one. That might not be too bad. 5. What did I want it to do? F inverse. F inverse of x. So these are questions I want to address today. G inverse of x. And in doing that, I think we'll cover quite a bit of stuff. Okay, so whatever we do, we'll just work around this space. And then let's throw the two composites now. P1, so let's do F G of x. Let's do G f of x. And okay, let's cut it there for now. So these are going to take into quite a bit of things. So if we think we go through that, I think we might cover everybody and then lead over into the graphing part.